Ladies and gentlemen, I am Dr. K. Swami, Coordinator Academics, Aditya University. Welcome to the online certification course on machine learning and GenAI. It's great to see your enthusiasm for exploring this cutting edge technology with us. This course is being organized by IEDU Vibu in association with Aditya Learning Academy, Aditya University. It is my pleasure to invite Professor T.V. Suresh Kumar sir, Managing Director, IEDU Vibu, to share his insights about this certification program.
On higher education and especially recognizing state of art, whichever is important for the faculty and students. Our experience says that majority universities are competing for accreditation and rankings, where we are also part of several universities across India. We observed that the activities required need to be structured in effective manner. In this context, partnered with Aditya University, Surampalem, Andhra Pradesh, and we observed that this collaboration, a variety of initiative in India itself, basically aimed at integrating state-of-art technologies for the benefit of both faculty and students. We have been particularly impressed by Aditya University's significant contributions to quality education, especially in the fields of AI and emerging technologies. The rarely qualified faculty and dynamic leadership have been instrumental in this endeavor, so that you are finding the sessions very enriching and beneficial. Wishing you all the best in your academic and professional pursuits. Thank you all.
Thank you, sir. Thank you for your enlightening words. Now it's my honor to invite Dr. M. Srinivas Reddy, sir, Deputy Pro-Chancellor of Aditya University, to say a few words about this course.
Yeah, thank you, Ayyappa Swami. So I am Dr. M. Srinivas Reddy, Deputy Pro-Chancellor, Aditya University. So briefly, I will explain about Aditya University. First of all, I welcome all of you to this online certification course on machine learning and generative AI. The importance of this certification is already explained by Professor Suresh Kumar sir, and we are very much thankful to IEDU Vibu for associating with us for conducting this online certification course. Our Aditya Engineering College, Aditya University was formed this academic year. But in 2001, we started our college as our university as a college with the name of Aditya Engineering College. So within this 24 years, we are running this college, and now this academic year we become a university. So our college was accredited by NAC A++. Ours is the first autonomous college in Andhra Pradesh who got NAC A++ grade, and 6. Our UG programs was accredited by NBA under Tier 1. So the importance of machine learning and generative AI is very much known to all the persons who are participating here. So nowadays, the artificial intelligence is taking prominent role in all the courses in engineering. In our curriculum also, we have incorporated wherever possible with AI. So we are very much thankful to the resource person, Dr. Sunita, to came forward to conduct this certification course from our AML department. She is having a very good, rich experience, and so I request all the participants to please utilize this opportunity. And regarding the attendance also, we are expecting at least 85%, 80% of the attendance from all the participants, so that you will get a certificate. So once again, I request all the participants to attend this certification program regularly and get maximum benefit out of this program. So thank you very much. Best of luck.
Thank you, sir. Next, I would like to invite Dr. S. Ramasri Madam, Pro Vice Chancellor, Academics of Aditya University, to share few words about this certification course.
Good evening, all. I am Dr. S. Ramasri, Pro Vice Chancellor Academics of Aditya University. I would like to tell you about Aditya Learning Academy. Aditya Learning Academy is the Center for Teaching and Learning at Aditya University, Surampalem, and it is established in this year to enhance the teaching and learning, foster collaborative partnerships, expand the digital education, and perform several other functions that facilitate Aditya University to be a leader in educational innovation and faculty development. Aditya Learning Academy, in association with iEduVibu, is organizing this online certification course on machine learning and generative AI, which is scheduled for 10 days from August 5th to August 16th from 6:30 p.m. to 8:30 p.m. We are also happy to announce that we have received nearly 2,000 plus registrations, which includes students, faculty, and even industry personnel. We are happy to see that these many people are very much interested in learning the newer technologies despite of their busy schedules. In this regard, we would like to thank Dr. T.V. Suresh Kumar sir, Managing Director of iEduVibu, for his support and for his confidence on us. This is the first online certification being conducted by Aditya Learning Academy, and these type of certifications would further be conducted every month. In this course of machine learning and generative AI, every day you would be having a 1.5 hour session right from 6:30 to around 8 to 8:15, and whoever are having some doubts, you can post your doubts in the comment box, and all these doubts would be clarified towards the end of the session, the last 15 minutes of the session. Or if it takes much time, these doubts can be clarified at the starting of the session the next day. So apart from this question and answer session every day, we also have planned a question and answer session on every Friday within these 2 weeks. And at the end, students, faculty, whoever are the participants, also have to write an examination, and participants will be able to receive a certificate if they attend to at least 80% of the sessions and score a minimum of 75% in the examination. I request all the participants to utilize this opportunity and learn more about the machine learning and generative AI course and use it in their day-to-day activities. I also congratulate Dr. R. Sunita, the resource person of this online certification course, for her effort in designing the course structure and then making it public. And I wish you all a happy learning. Thank you.
Thank you, madam. Thank you for your information about Allah and the workshop and that certification course. Finally, I request Dr. Sunita or the resource person for this certification course to take over the session.
And myself, Dr. Sunita Racharla from AML Department of Aditya University. Today, it's my pleasure to welcome you all for this 10-day certification course on machine learning and GenAI, starting from August 5th to August 16th in the evenings of 6:30 to 8:30. So actually, from the registrations, I'm so thrilled to see a diverse group of participants who are including students and faculty, and most importantly, the different areas of industrial people, industrial professionals. So I'm so thrilled to share my views with you all. So let's begin our certification course, and hope you will enjoy the sessions. And before going to this FDP, I would like to inform you that from the registrations, I can see there are a few students also there who are mostly are from completely basic idea of machine learning, or mostly there might be no idea of machine learning or artificial intelligence or anything. and few people may be faculty, so they'll have the basic idea. And if you are very experts in that, and industrial professionals, of course, few people are from the basic level of understanding in machine learning, and few are the experts in. So I think all types of grouping people are there. So our sessions will cover all these types of concepts. Like I'll start from the basic, and I'll try to cover all the fundamentals of machine learning. I'll try to cover all the fundamental concepts of deep learning and all the practical sessions on these two, and then we'll move on to the medium level of any optimization techniques, or any what the limitations are, how we can overcome the limitations of machine learning, and how we can improve the metrics of the machine learning, different metrics we can have in machine learning. So how can we improve that metrics of machine learning? And then at the last, we'll go for the GenAI, which is some advanced topics of the machine learning. So our certification course is concentrated on these three levels. So starting, it will be the basic fundamental concepts of all the machine learnings and deep learning. Then we'll start with the medium level concepts and some hands-on sessions, and then we'll cover all the advanced applications of the machine learning, deep learning, and GenAI. This is our 10 days of schedule. And before going into that certification course, I just start with the day with a bigger smile. So while surfing the net, I just gone through this meme. So just assume one day you wake up and your computer told you that you are completely busy in your working, and just you forgot to how to play some games. So you buy a ticket and go and watch a cricket match. So how do you feel that if your computer is telling to that? So just think that, and this is not that much very far to our future. So very near we can face that also. Means that is just like our machine learning. So machines will learn what we like, and they'll give you some advice. You do that, you do that, you do that. So or for example, if you wake up in the morning, your coffee machine directly says you today you want to drink some Nilagiri coffees or black coffee with some special toppings on that, and it will when you wake up, it already make that the particular things and give you that. So just feel that experience how it will be. So that is our future actually, machine learning future. So before going into that machine learning concepts of our certification program, I just want to tell you why you people have to learn this course, why you have to register for this course. So just think of our daily lives. So morning when you wake up, I just want to surf your smartphones. So how an Amazon, ever you think how your Amazon website will give you the recommendations of a particular product, if you have seen somewhere in your YouTube videos, or yeah, ever you think that how Netflix can know your favorite movie, or some Savana Spotify music app, how it can give you the particular playlist, whichever songs you like. So all these things, how a machine say, how a smartphone can know that, or else in Google Map, how it can know where some traffic is there, where that empty road is there, where the blockage is there. So all these things, how a machine can do. And ever you think that, and or else if you want to go to some healthcare systems, so how can a particular from the CT scans or some particular algorithms, how a system can predict that this is the level of the disease, I mean this is the stage of the disease, it is in the early stage, it is in the medium stage, it is in the last stage, and this is the particular medicine for that, how a machine can do that. So all these things combine that we can say that some magic is there in that machines. They are learning something from that. So that is called a machine learning actually. So when we are completely going into that machines, when machines are almost taking 3/4 of our daily life, so it's our responsibility to learn their language. We have to improve the understanding between the machines and humans. So that is the first primary reason you have to learn this machine learning first. And the second reason is you might have think that we still have so many traditional languages like so many programs like we have C, we have Java, we have C++, we have Python, and so many programming languages are there. But why we have to learn machine learning? Why we have to go for a machine learning? So I'll tell you some example. It's just like I want to go for a trip. So traditional programming is like I want to go a trip to with my friend. So traditional programming, like if you take an example of C, so traditional programming is like it's like before itself, before going to the trip, take a paper and write everything where you have to stop, where you have to take the breaks, where you have to sleep, what places you have to visit in a particular area, and where you have to stay. So everything pre-planned, write it on a paper, and what type of bus you have to take, which number road you have to use. So everything pre-planned, and you have to follow each and every step like that. You don't need to, there is no possibility of creativity or any other thinking. So in front itself, you have to prepare everything, each and every rule, and then you have to follow that. If you're not following that, the program will be upset in somewhere. But machine learning is like, it's nothing, no plan, nothing. Just take a bag and go on a road trip. Whatever may be the road, whatever may be the place, you just know the destination. You have to reach that there. That's it. So take a bag and go. So in between, whatever experiences you face, there you learn something and you will explore the data, explore the environment. You learn from something. From that experiences you learn and you'll feel, you'll enjoy. Sometimes you cry, sometimes you fail, sometimes you win, but you learn something and you'll reach the destination. So I think you'll understand the difference between those two. So traditional programming, there is no creativity actually. It's completely pre-planned. And machine learning is completely about we know nothing. Just you explore the data. The same things we are going to do with the machines also. So like another example I'll tell you. So if I want to do a program for a traffic signals. So in C, if I am using a C language, so in the C language, what I'll do? I have to give a if and for loop, and I have to loop like if red light comes, I have to stop. If the green light comes, I have to go. If the yellow light comes, I have to be ready. So I have to use loops. I have to ask the machines. So if red light is there, you just stop. If the green light is there, you just go like that. But what happens in machine learning? We are not giving any rules. I just will tell that you first learn what is a red color, red light. You just learn what is a red light. Then you first learn what is a red light, and then if something you see like a red light, you take the action. You take the action like the output will be stop. So here we are not giving anything. We're asking the machine to learn about the red light, about the concept. You learn the concept, and once you learn the concept, you just take the action. That's what we do in machine learning. So that is the main difference between traditional programming and machine learning. And by doing this, what will happen? What is the advantage? For example, I have a doggy maze, and I want to do a program for the doggy maze. I'm using first C, so I'll give some inputs, and I gave the program also, and the machine predicted as yes, it is dog. So I got the output as dog. But now I just little bit I changed the image, somewhat I took the image as a front image, and now I just turned it, and now the dog image is a little bit in inclination, something like something it is inclined to some left angle. So what do you think? Language can do that? Again, you have to take the input features, and again you have to do the program. then again you have to get the output. If that is the same image, if it is turned to some right, what the machine can able to read that? No, again you have to do the program. But what will happen in machine learning? In machine learning, instead of giving the input and program, what we'll do is we'll give the inputs. So we'll call it as features in our machine learning. So features means we'll just give you, if the eyes are like this, if the nose is like this, if the tail is like this, if the skin of the dog is like this, you think that this output is a dog. So here we are giving input and also output. In the C, what we did? We gave input and also we gave the logic program and we are expecting the output. But in machine learning, we are not giving any program here. We are just giving the inputs. So this is the nose, this is the eyes, this is the tail, this is the skin of the color. Then if four these things are similar for in whatever input again you are getting, if these features are similar, then you predict that that is a dog. So what we are teaching to machine, we are training the machine with different images and in all images, these are the features. If all these features are similar, then the output should be dog. If any of the feature is not matching, then the output should be not dog. So that we are training to the machine. So I hope you'll understand the machine learning. So in machine learning, we are not giving any program. We are just giving the inputs and also outputs, and we are asking the machine to learn the relation between input and output. So after training so many images, after training with the so many inputs and outputs, we are asking the machine to learn the relation between input and output. Then after getting the relation, it will try to build a logic. That logic we'll call it as a model in our machine learning, or logic in our machine learning. So depending on that model, when you give a new image, then it will easily predict that if the feature is similar, whatever it trained before, then it will predict easily that is the output. So this is what happens in machine learning. So like that, so many advantages are there in machine learning compared to traditional programming. One thing is, already I told you, adaptability, like going into the journey. So we adapt to any environment, whatever may be the data. You just analyze the data, explore through the data, and you train with the data, you train with the features, and you learn. So adaptability and more important in machine learning, and it is the best feature in machine learning. And one more thing, one more advantage of machine learning is whatever when you give a large sets, large data, then machine learning will work better, best actually. So actually, they say it's a proverb actually. If the large data sets are there, the more efficiency we'll get from the machine learning. So which is impossible in the human level or traditional programming. When the large data sets are there in traditional programming, the errors are very more. So debugging is difficult in the traditional programming. But in machine learning, when it is a large sets, the training period will be more. The machine trains more in the with the large data sets, and then it will accurately predicts more. So the accuracy will be more. So these are the reasons why you have to learn the machine learning. And these sessions, these 10 days of course will cover all these things, all the basic concepts, and almost in every class we'll see the hands-on sessions, how we can use all these things. And whatever I taught in the theory, that the same thing will affect the influence in the lab sessions also, I mean practical sessions also. So you will see the difference between the theory part and the practical sessions. Now just let me go through the day schedule, 10-day schedule, to have a clear picture with you all for what I have planned each and every day. So this course I already told you, it will start from 5th June to 16th June, and 4 days session will be the classes. and one day each Friday. This week Friday and next week Friday will be completely question and answer sessions, and there you'll have a quiz session also, like just a simple test. So in that question and answer sessions, whatever questions, whatever doubts you have, or whatever lab sessions we have practiced in these all 4 days, that any doubts are there, you can ask me. It's like interactive sessions. So I'll answer you for all your questions. And if any doubts are there, if any where you stop it, then you can ask me that also. We'll see on that Friday. Of course, on each day we'll have the last few minutes will be the question and answer session. So every day you'll have you can rectify your doubts itself. And that is a completely question and answer sessions. So just now let's see the day-to-day schedule. The first day will be introduction to data pre-processing. So I already told you, I think you have a basic idea of machine learning. So machine learning completely works on the data. So if you give more data, it will works better. So data. And data means I cannot give whatever data I get, I cannot give it to machine, because machines automatically it will not understand. Humans will have the nature of the intelligence, basic natural intelligence we have. So if I get a data, I can easily say this data is very complicated. This data is very easy. The data is structured data. But machines cannot identify that. We have to tell that this is a raw data, this is a clean data, or this is not clean, this is structured data, this is unstructured data. So we have to tell that. So data pre-processing is basically analyzing the data. So before going into the machine learning algorithms, what things we have to take care of the data? That parts we will learn in the first day of, today. So in data processing, we are going to deal how we can collect the data, in how many ways we can collect the data, and how to clean the data, in how many, what are the techniques to clean the data, and data, how to transformation, how to do the transformations on a particular data. And if the data is very big, and if it is a large scale, and if it is not, not particularly accurate to use for machine learning algorithm, how we can reduce a particular data to improve our storage capacity or computational speed of our machine. So how can we reduce that? So that we will learn here. And also outlier detection. So outliers means which are not completely consistent with the data. Like for example, I have a data of some salaries, and suppose let's say I have 100 rows of salaries. In that, some 80 rows are belongs to in the range of some 3,000 to 7,000, and the remaining 30% of data belongs to the salary of some 20 lakhs to 40 lakhs. So means that the 30% or 30 rows are completely different with this all 70 rows. Means 70 rows are in the range of some 3,000 to 5,000 itself, but that are some 20 lakhs to 40 lakhs. So when you plot that points on a graph, so all these points up to 70 rows, it will come from here, and that 30 lakhs, 20 lakhs to 70 lakhs will be somewhere away. So which are, we cannot plot these two. We cannot relate these two to do some statistical method, to apply some statistical methods on these two. So we call that particular things will are outliers. So that is not related to this one. So if you consider that when you do some machine learning algorithms, it will affect the accuracy. Maybe our whatever model we are building, whatever algorithm we are building, whatever logic we are building, it may affect, because of that it may affect these things also. So here the major things are the 70 rows. So we have to consider that what are in that range or not. So if it is not in the range, that we call it as outliers. So that we'll see how to detect that outliers, we'll see here in this class. And the last one is data visualization. So this is the best part of data pre-processing. Data visualization, I think already a few members will have the idea. how to how to represent the results, how do you outcome that your results. So how beautifully you are going to represent your results. Yeah, directly if I say my some accuracy is 90% and the same 90% if I represent through a graphical picture, so that there will be some difference. So to view the graphical pictorial view is very more better efficient compared to a numerical value. So how beautifully you'll represent your results, that comes in data visualization. So in data visualization, we'll see how many techniques are there to represent that results, to visualize the results, visualize the outcomes, and in what ways we can do. And in particular results, in particular chart we can use that. How we'll use that, we'll see in our session. And in the second day, I mean tomorrow, we are going to jump into our machine learning fundamentals. And here we will see first what is the main difference between artificial intelligence, machine learning, deep learning. So most of the people are confusing that all these three are same, or most of the people don't know the difference between these three. Just like I'll tell you some example. So you have a pet dog in your home, and AI is like, and you are training the pet dog to catch some stick. You're just throwing a ball, and you asked your dog to pick that ball. So that is the action of the dog. So now what AI do is, the dog will go and pick that ball, and it will take the decision, and it will come to you in whatever maybe the way it will come to you, and it will give you. Machine learning, what it will do, machine learning, it trains that. So every time when it goes to the ball, I just give some reward to that, and it will train that when I reach the ball, so I am going the better way. If I am not going to the ball, if it is instead of catching a ball, if it is catching some stick, then it will get some punishment. So in that way, it will train itself, and what in many ways, in number of times, it will try to catch a ball, and then finally, whatever may be the ball and whatever may be the shape, and wherever you throw that ball, definitely it will come and pick. That is machine learning. So by training, it will improve its performance. And deep learning is it just throw a ball. So instead of catching that ball, only catching that ball, it will do some other works. It will create itself, and it will do some other works. It will with that, along with that ball, it catches the newspaper also, it will bring to you. So deep learning is in some is just like machine learning will give some features. Maybe in that dog image, whatever features we are giving, that is not enough. Deep learning, it will create some other hidden features, and it will give you more accuracy. So machine learning cannot do that. It will not be able to create that many features, hidden features. So deep learning is completely just like our brain, our neural networks. So using the neural networks, it will create the hidden features. It will create more inputs, and from the more inputs, it will create so many patterns, and it will easily recognize that pattern, and then the accuracy will be improved in deep learning. So that is the difference between AI, ML, and DL. And of course, reinforcement learning. Reinforcement learning, as I said, rewards and punishments. So when you reach the destination, you'll get a reward. When you cannot able to reach the destination, you'll get a punishment. So that is what we see in reinforcement learning. And now generative AI. Generative AI is completely advanced of all these things. So it will generate something. So just like only along with the taking the ball, it will generate in between something, and it will taking the newspaper. It will generate. It will take some coffee or some biscuits for you. It will generate by itself, and it will do that work along with the given work. So that is generative AI. Till on the black canvas, it will generate something by itself, and it will give you the result. That is generative AI. That we'll see in our second day. So the main differences between all these things. And also we'll see the more differences between the traditional programming and machine learning. And of course, we'll see what are the main advantages of machine learning and applications of machine learning where we'll use that machine learning in nowadays. And of course, we'll see the issues. So with all these advantages, we have so many issues in machine learning. So that's why we are going to do the optimization every time. Whenever you are doing a machine learning project, you have to do the optimization part. So why you have to do the optimization? What are the issues in machine learning and how to rectify that? That we'll see in the second day of our program. And with that all, here we'll see the main types of machine learning. There are three main types of machine learning. One is supervised, one is unsupervised, and reinforcement learning. So we'll see the difference between these three and with a few real-time examples, of course, and some funny memes we'll see. And here we'll see some 2 or 3 algorithm of hand sessions we'll see, mostly KNN, few at least 3 or 4 we'll cover here. And we'll try to see that on hands-on sessions. Mostly I'll cover KNN, naive Bayes, decision tree, and a few any other time is there. We'll see SVM, all these things we'll see here, and we'll see how to do that on practical session. And on the day 3, we'll see the other remaining 2 types of machine learning. One is unsupervised and reinforcement learning. And in unsupervised, we'll see how to work on practical of k-means clustering. And of course, we'll see DV scan clustering, hierarchical clustering, all these three we'll see on the hands-on sessions. And of course, we'll see reinforcement learning, Q-learning, some few algorithms we'll see in reinforcement learning, and see how the policies will be awarded and rewarded and punishments will get, and then how the accuracy will be improved. All these things we'll see in the practical sessions here, reinforcement learning. And on the 4th day, we'll see all the optimization techniques. So in the day 1, day 2, I told you the issues of machine learning. So in the 4th day, we'll solve all the issues of machine learning. Of course, already we have worked up to this day, we have worked on supervised learning algorithms and unsupervised learning algorithms. There we'll get some accuracies, and of course, some losses will be there. So here the same practical will take here, and with these methods, PCA method, gradient descent, all these things we'll use in the practical sessions, and we'll see how to improve that accuracy. Suppose we have get 86% by using this, how we can improve that, how we can reduce the training loss, how we can reduce the testing loss, all these things we can see here in that 4th day. And next day will be the Friday. So I already told you this is the question and answers day. So you can ask me anything. If you have any doubt in the practical sessions also, you can clarify here on that day. And the next session will start on next week of Monday. And here we have completed. I hope you will get the basic idea of machine learning up to this level. So then we'll go for deep learning sessions. So in the deep learning, we'll see how to form the neural networks layers, and in each layer, how many nodes we have to keep, and how to form the number of layers. All these things we'll learn, and we'll see what is the main difference between machine learning and deep learning, and how the features will be created itself in deep learning. That we'll see here. And of course, here before learning the deep learning, the mathematics base is important. So we'll just remember some basic concepts of the mathematics, like probability and matrices and different operations of matrices. And about we'll learn about the scalars, vectors, and matrices and dimensions. And we'll see some hyperparameters and parameters. So all these things we'll learn on the 5th day. And the next day will be all the loss functions. So once you get the result, whether that result is almost near to whatever result we have in our database, whether any difference is there, whether the machine able to predict correctly or not, how much extent it is going to predict, and what are the metrics we have, and how do you decide your algorithm is your model is best, and on what on what criteria you can say your machine is your model is predicting accurately. All these things, all these concepts here we'll see. And of course, activation functions are there. Different activation functions we'll use in neural networks. So we'll use ReLU, we'll use TANH, we'll use sigmoid, all these things. So we'll see what is the importance of each and every activation function and how to use that in what particular case we'll use that. That will be in our day 7. And of course, all these sessions will be on practical only. There won't be any theoretical sessions. And this is the next one is loss functions. There are different loss functions, and how to get that loss function and what type of loss function we have to use a particular algorithm, but particular problem. So that we'll see here. And of course, regularization. Regularization is to reduce the dimensionality actually. So that we'll see here whether we have to use L1 regulation or L2 regulation, and what is the difference between these two. And in particular, which cases we have to use that regularization, we have to see in this particular day. And the next session will be completely about neural networks. So here we are going to see the types of neural networks. And of course, we have different types of neural networks: multi-layered neural networks, feed-forward neural networks, back propagation neural networks, and of course CNN, RNN. So where we'll use the CNN, where we'll use the RNN. So and what is the difference between these two? How to build the layers? All these concepts we are going to see here in this session. The session will be about GenAI. So up to this level, you will have the basic concepts, and of course, how to use the practical concepts of machine learning and deep learning. All these things you are aware of that. So in the last session will be some applications of GenAI. And here we'll see a few algorithms of GenAI and how to apply that GenAI in practical sessions that we'll see here. And of course, the last session is exam and certification exam, and your question and answer sessions will be on the 10th day. So this is the brief schedule, what you are going to do on the 10 days of our schedule. And so I hope you see the levels, how we divided that for all the basic people, medium people, and advanced people. So if you have to get the certification, you have to attend 80% of our classes and should write the exam, then you'll get the certificate. Now let's go to the our session. So first one is the first day I already told you data pre-processing. So before going to data processing, we'll see what is data processing. So this is the real thing actually happens. So this is a very cute puppy. Actually, whatever data we are going to consider for our machine learning projects from Kaggle or somewhere we are downloading from some Kaggle will download, some websites will have in Google. If you type the data set, you'll get so many data sets. That's like just a cute puppies. But in real time, it won't be like that. The real time data sets will be like this. So if you use that type of data sets for your machine learning project, automatically it will kill our machine learning algorithm. So you cannot use that. So for that purpose, we are going to use the data pre-processing term. So the name itself indicates that the data pre-processing. So before processing anything, you have to do some operations on the data. What operations you can use? You have to clean the data, you have to reduce the data, you have to make the consistency of the data, you have to remove the duplicates of the data. So all these things you have to do. So that operations, everything combining all these operations, we call it as data pre-processing. So making the data useful for our machine learning algorithms is nothing but data pre-processing. Making the data for useful to our machine learning algorithms. So machine learning mainly used to improve our accuracy, improve the prediction level. So to improve that, the data should be very clean. So to make the data as it is, we use them data pre-processing. So machine learning, I already told you, machine learning is subset of artificial intelligence. So it will learn from the data, it will train from the data, it will learn from the experiences from the data. And then finally, after training so many times, it will predict the output. So that is machine learning. So machine learning actually consists of three main parts. First one is, as I said, data pre-processing, and second one is modeling, and third one is evaluation. So with these three steps, the complete machine learning part will be completed. So data pre-processing is nothing but how we are collecting the data, from what type of sources we are collecting the data, how we are cleaning the data, how we are applying some operations on the data, and then how we are going to split the data into some training and testing. Why we have to split the data? Because suppose I have 100 rows of data and I am going to give, if I give the 100 rows of data to the machine, then if I give a new input, it will predict something, but I don't know whether it is predicting good or not. So what I'll do is, suppose I have 100 rows of data, what I'll do, I'll split the data into some. So suppose, for example, I have splitted the data into some 70 rows at a side and some 30 rows at a side. So that 70 rows, I call it as a training data, and that 30 rows, I call it as a testing data. So that training data I am going to give to the machine and ask the machine to train itself with the 70 rows. So it trains so many times with that 70 rows, and it will learn the relation between input and output, and it will create some logic, some relation between input and output with that 70 rows. But here we are keeping the 30 rows at a side. We are not showing this 30 rows to the machine. Machine don't know we have still 30 rows, but we know in actual our data we know the input and output. So we call that as test data. So what we'll do, after training with that 70 rows, now I'll give something, some new input from these 30 rows. Here I know the output. Now I'll give the input. Machine will predict something. Now I'll compare that output with whatever output I have actually here. Now I can see the difference, whether both are same, then I can say, yes, the model is correct. If both are different, then I can say, now the training is not enough. So you have to train it again, and the machine has to predict more. So that's why we have to split the data, because just we want to see whether the model is the algorithm, whatever the machine created, whether it is working correctly or not. So that's why we are going to split the data into training and test. So this is the three steps will be done in our data pre-processing. And the second thing is building the model, modeling. So modeling is nothing but once you split the data, you supply the inputs to the machine, and so you will give the outputs. Outputs also you'll supply to the machine. It will read the relation between input and output. It will create some logic between these two. So that is nothing but the model, the building the model. So it will create the, after training so many times, after going through so many inputs so many times, it will create, oh, this is the relation. If the feature is like this, the feature is eyes are like this, then this is the dog. So if the input is like this is the output. So it will create the relationship between these two. So it will create the model. So that is nothing but building the model and training the model. Now, after building the model, again you train with so many inputs and training the model. Then the remaining unseen data you give it to machine and make predictions just to evaluate whether the model is correct or not. So make the predictions. So this is the second step of machine learning. And the third step is evaluation. So evaluation is nothing but after training is over, testing is over, then you completely give a new output, then it will predict the whether it is predicting the correct output or not. So it will evaluate, and you will evaluate the metrics. So metrics in the sense, some statistical method should be there to say whether my machine is correct, by whether my machine is predicting correctly or not. So in machine learning, the metrics are like accuracy, precision, recall, or F1 score. So all these things, whether the accuracy is 99%, I can say my machine is superb. It's working superb. Whether the accuracy is 30%, I can say no, it's the model should try it again itself. So like that, some metric should be there. So here, actually this is the evaluation of performance metrics, and then we have to make the metric. So whether the machine model is perfectly built, or again we have to remodel it. That we have to decide in this step. So these three combination we call it as machine learning. So in that, our first step is pre-processing. So as I said, data pre-processing in machine learning is the preparation of data through cleaning, normalization, and feature engineering to improve model performance and accuracy. So data pre-processing is mainly used to improve the metrics. So main metric is most of the cases it is accuracy. So improve the performance and accuracy. So accuracy should be improved. So to improve the accuracy, we have to do all these steps in our pre-processing. The steps are cleaning, normalization, and feature engineering. Don't worry, we'll see step by step in the coming slides. So, the main thing is you have to decide the quality. So main thing data pre-processing is to decide the quality. So to get a better quality of the data, how we'll decide which is the better quality, and what factors you will decide the quality is the best or the quality is the worst. So these are the factors which influence the quality. So first one is accuracy, whether the data you are using, whether the data is correct or not, and completeness, whether the data, whatever data you are getting from the real world, that is completely, either it is completed, or if it has some null values, or if it is not if it is incomplete, whether I can able to fill that incompleteness, or it is impossible. So that things we should know. We should know, and we can able to tell, yes, this is a completeness of data, this is complete data, this is incomplete data. All these things we can able to tell. And the third one is consistency. Consistency means, for example, data, if you are getting a data and somewhere some data are there, time series is there. So somewhere someone kept the data as some 3 dash 7 dash 24. In somewhere, some person in the same data set, some person kept 3 some July 24. In some person somewhere, someone kept like 03/07/2024. Actually 3 are correct, but completely 3 are different in the same data set. So the consistency is not there. The same like time series. Somewhere may give 4 p.m. Somewhere someone may kept like 16.00. So the meaning is same, but the data should not be, machines cannot understand the different patterns. So you have to tell that the data should be in a particular manner, in a particular format. So consistency in maybe in the sense of format, or in the sense of types, in the sense of numerical values, in the sense of names also. Suppose if it is a string, and I can say myself, like in somewhere I kept like Dr. Sunita Racharla, or somewhere I can kept Dr. Racharla Sunita, then machine cannot able to understand whether that is the same person or not. So I can say that is not consistent. So it should be same everywhere. That you have to take care, and this is the main problem in machine learning data. So that you have to see in your machine learning pre-processing. And next one is timeliness. So this mostly important in our stock market or weather prediction, whether the data is timely updated or not. So if it is not timely, sales prediction, forecasting, so all these particular areas, banking sectors. So if the data is not timely updated, then the prediction, of course, it will not come as usual. So next thing is believability, and believability is whether the data is coming from a trusted source or some viral source. Some virus is there, that we have to decide. Then we have to take care of that type of data. And the last one is interpretability. So whether everyone can able to understand the data easily or it is very complex data, that we have to decide. So these are the metrics, these are the factors which will decide the accuracy quality of the data. So next we'll see what are the main major tasks in data pre-processing. Now I'll just have I'll take a 5 minutes break and I'll share you some Google link. I'll share you some Google links. You just try to some 5 or 6 questions are there in that sheet. That is the complete basic level of this thing. So just to try to attend that sheet, whether you are getting some understanding in machine learning or not. So after 5 minutes, we'll again join and we'll see the major tasks in machine learning. Thank you. Welcome back, participants. So I hope everyone attended that quiz session, and for you, I hope everybody are able to attend that 5 questions that I have given you. Those are actually very basic questions. So now let's move on to the next thing, next slides. And here, the first pre-processing technique is data cleaning. So the first pre-processing technique is data cleaning. And data cleaning, it's a combination of 3 things. So one is whenever there is a missing data, we have to clean it. And whenever we have a noisy data, we have to clean it. Whenever we have an inconsistent data, we have to clean it. So we'll see one by one. Missing values. So missing values means, suppose we have an data that's structured, let's say Excel. Some 10 rows of data is there. In 10 rows of data, in particular some 4th row or 3rd row, in particular 2nd column, one element is missing there. So nothing is there in that cell. So as a humans, I can easily identify there is nothing, no value is there in the data set. But how can machines will identify that? They cannot know that whether that is an empty cell or some amount is filled in that cell. So we call that as a missing cell. So we have to tell that machine that is called a missing cell. So missing value. So whenever missing data is there, when you are not showing that machine that this is the missing data, then machine cannot able to predict that. Then error will occur and the accuracy will automatically decrease with that missing data. So what we'll do in that particular cases means, if there are so many missing values in that data, and if the data is very used data and so many missing values are there, and of course most of the numerical values are missing, then what we'll do is, instead of filling all the values, we'll try to ignore the values, or we'll try to remove that values without changing the meaning of the data. We'll first analyze the data, we'll see the data, whether by removing that particular column or row, If the meaning is not changing, then we'll remove that data. So that is ignoring the missing values. This is one type of cleaning the data. Second one is fill manually or fill computed value. So if we remove that particular row or column, then the meaning is changing. Means meaning in the sense, I mean, suppose I have a some 10 rows of data. In that particular row, one column is like A's. In that particular, depending on that A's, I am going to predict the salaries. So that is my project actually. Depending on the age of the human, I am going to predict a salary. So at particular age, what is the salary? In that particular row, some third row, after 30 years of age, it should be 40 years. There, that particular thing is missing. And now I have the salary, something is there in my output. So I cannot remove that 40 years there. I cannot remove that cell because if I remove that cell, the meaning will be changed. So I cannot able to predict the output. In that cases, what I'll do, I cannot ignore that. In that cases, what I'll do is I'll try to cover that value. I try to fill that value using some statistical methods. Here that the statistical methods are by computing mean, mode or median. We'll use any of the technique which is applicable for the particular application for the particular project. And depending on that particular statistical method, if we use either mean, either mode, or either median, or some other statistical methods, we'll fill that value in that particular cell approximately, and then we'll calculate the accuracy. So while training, automatically we'll adjust the value. That is nothing but fill manually or fill computed value. So this is how we'll rectify the missing data. The next one is noisy data. So noisy data is nothing but, for suppose I just want to do a project like the same age and salaries. So now I have the data of a particular age, and at the particular age I have the salary. In that data set, including that age and serial number and person's name, I have the particular person address, the particular person sex, the particular person some phone number, some 10th qualification or graduation, whatever, very some features are there in that rows. So to do that project age and salary, most of the things like address, I don't need. Address maybe for my particular project, maybe that is useful, but for my particular project, maybe that is not that much useful. So if I use that thing also in my project, that will create so much noise in my project. That is unnecessary for me, additional feature for me. So I'm increasing the memory or space or storage space and decreasing the speed of my program. So all these things happen. So I'm reducing my accuracy of the machine learning model. So what I'll see, which is not useful for my project, I'll try to recognize that as noisy data. So I have to remove that noisy data. So for that, there are three processes. First one is binning. Binning is just like dividing that data into a small bins. So suppose I have a 100 rows. Instead of cleaning the 100 rows at a time, first I'll divide that 100 rows into some small bins, like 10, 10, 10, 10 rows. I'll divide, and each 10 rows of bin I'll clean at a time, so that the cleaning is most perfect, and then I can easily identify whether that is a noise data, whether that is not useful for me or not. So I can clean. Then after cleaning all the 10 bins, all the bins, then I'll aggregate those bins and I'll try to make the clean data. That is the process happens in binning. So we'll just divide that into a small bins, and each and every bin will be cleaned again and again. And then after cleaning all the bins, we'll aggregate all the bins, and we'll try to make a cleaned data bin. So that happens in binning. So here using bin, the noise will be erased or removed smoothly. So it is the best thing in binning. And next one is clustering. Clustering actually happens, it is a one type of machine learning algorithm, unsupervised learning. We use clustering. So clustering is just like grouping something. So suppose I want to do a project like dividing the fruits. So I want to, I don't know the name of the fruit, but I want to divide the defective fruits and non-defective fruits. So whatever may be the in that defective groups, defective fruit group, whatever may be the fruit, whether that may be an apple, that may be a banana, that may be a pomegranate, or any fruit may be there. I'm not giving any labels there. It's just a fruit, but whether it is defective or non-defective. So there I'll give some similarities. So if it is a defective, then I'll give some similarities like some defect is there in the shape of the fruit. Some color may be changed in the shape in the fruit, or some smell is coming from the fruit. So I will give some similarities, some conditions. Depending on the similarities, the machine will able to group that particular fruit, whether that belongs to a defective group or non-defective group. So in clustering, that works on the similarities. So similarity, based on the similarity, we just group that. And after grouping, we'll clean each and every group. So there we'll see, of course, all the elements in that cluster will have the same similarity. So it is easy to identify whether the data is noisy or it's useful. Then we can clean it. And the next one, remove manually. If the data is very less, very small, not a bigger data, then automatically we'll see that we can identify that a person, a supervisor will identify that, and manually you can remove that noise, and then you can process the data to your machine learning algorithm. So this is what happens in noisy data. And the next one is inconsistent data. So inconsistent data, I already told you what you call as inconsistent and consistency. The data is not similar from top to end. So there may be differences. Maybe the meaning of the data is same, but the way you represent is different. Just like dates. Somewhere you represent with the dashes, somewhere you represent with slash, somewhere you represent with characteristics. So the representation is different. Maybe the format is different, or maybe the location. Suppose if you are taking the geolocations, so the same India, Rajahmundry, I can represent something like some using some GPS. I'll represent in some way, and some person will represent the same Rajahmundry geolocation will be in some way. Both are the meaning are same, but the consistency is different. Both are inconsistent. The machines cannot able to identify that. So whenever you are using a data for your machine learning algorithm, the data should be in a particular format. It should be the same from top to end. Then only the machine can able to understand. If there is no chance of transforming the data into particular thing, different format, then you have to tell that machine before itself, this is the formats we are going to use. So these are the formats we are going to give. So you have to remember that we have to tell before. So that inconsistencies we have to eliminate. So these are the three things what we do basically in our data cleaning. So which is the first property of the data pre-processing. And the next step in our data pre-processing is data integration. Data integration actually happens in medical field. For example, CT scans. So if you are doing some medical project, healthcare systems, and you are going to scan, the CT scans are there, and you are going to analyze it, doing a project analyzing that CT scans, and you are going to predict the disease. So using a one CT scan, you cannot do, you cannot predict, you cannot build that machine learning algorithm. So you have to collect so many CT scans, and each CT scan image will be saved in different data sources. Maybe one will come from one hospital, one will come from one hospital. So from different data sources, you'll get that information. But different data sources you cannot use for your pre-processing techniques. So what we'll do, from the different sources of data, we'll combine and we'll create a bigger data source. Here, we'll integrate the complete different data sources and we'll create a bigger data source. Then that we'll use for our machine learning algorithm. So this process is called data integration. So mostly this happens in medical field. This is the second technique in our data pre-processing. And the third one is data transformation. How we are going to transform from one format to another. So basically data transformation is like, suppose I am doing a project and here I can have the representation of some locality of city. Now I don't want that city. I want to convert that low level data source into higher level data source. Like just want to convert that city into a country. Now I want to transform the data format from one thing to another thing. So how I'll do that? So for that, there are few operations we have for data transforming. First one is smoothing. This is the first operation in data transforming. For example, here we'll see. For example, to do the smoothing. So smoothing is just to reduce the noise and variability in the same data. Some differences are there that we are going to remove that by filtering, by averaging or filtering. There are two examples here for the smoothing. First one is moving average and second one is exponential smoothing. Suppose here we have the daily stock prices for a year. This data we have. And to identify trends, instead of using a daily predictions, we just take the 7-day prediction and we average that. So in the next data source, instead of having a daily representations, we'll have the average of this 1 week representation and we'll use this 7-day moving average for our prediction. So that means that from daily to 1 week, we are just transforming the format. That is called smoothing. Or one more example is exponential smoothing. For forecasting, sales forecasting and weather forecasting, we'll just use a recent data because suppose sales forecasting, the last 10 years data is useless for us. Only recent data we want. So for that, we'll just use the exponential form. Instead of using daily predictions, we'll use some year predictions or monthly predictions. We'll just use the exponential form. So one format we are going to change. That we'll call it as data transformation. And next thing is generalization. The next step in same data transformation is, first one is smoothing, second one is generalization. So generalization is nothing but, as I said, from low level data source to transforming that low level data format to high level data format. Just like from city to, I just want to convert that into country. So low level to high level. So that is called generalization. Or else here, instead of taking the individual ages, I'm just generalize that ages into some groups. So the age may be whatever age I am taking, some 22 years of a person will generalize it to this range. So I'm just taking the generalized range and I'm keeping that person in that group. I'm just generalizing that particular thing to a particular range. That is called generalization and we call it as binning the data. So as I said, binning, I'll create a few bins and each bin will consist of a range. So here the bins are 18 to 24 and 25 to 34. And next, geographical generalization. So here the pin codes, zip codes. So zip codes, instead of using the cities as a lower data sources, we are just upgrading to country zip codes or country pin codes or something. We're just upgrading that. So that is called geographical generalization. The third one is normalization. Normalization is one type of data transformation. So in normalization, it's just like scaling something. So if you are, for example, I have so I have a data set of some A's again, some A's of like some 25 to some 70 in the range of A's that I have. Next column will be like person income. So the person income may be somewhat in the range of some 40 lakhs or 50 lakhs. So you want to represent that in a graphical thing. So one is like X and Y axis. One is like in the range of 20 to 70, and one is in the range of some 20 lakhs to 40 lakhs. So we cannot able to do that on graph. So what we basically do, we will use a scaling between these two to make a range. These two we want to represent on a graph, but in real time, when that range is like this, we cannot do that. So what we'll do, we'll apply a scaling, a min-max scaling we normally apply in our machine learning, minimum and maximum normalization. So we'll make both the things a particular range. Then we can easily plot that and we can easily represent that. Then we can easily predict the features and the machine will be able to build a loss. So this is the general formula what we use in our normalization in our machine learning projects. Next one is attribution construction. Suppose I have few features, 3 features in my data set, and I want to predict an outcome. Suppose yes, here I have considered the date and some year I have, and with that too, I can create one more feature by myself, or else the machine can create the feature. Using these two, the machine can create the feature of time. So attributes automatically it can create. So that is nothing but attribution creation. So feature engineering, if you have a data set with the date and time, you can create with these two features, you can create hours. So one more feature or one more attribute you can create, the machine can create. That is, one type of attribution construction. And second one is ratio features. From the features, from the available features, when those features are not efficient or not sufficient to predict accurately the accuracy, then you have to give the ratios of few features. From these two, whether I can able to construct some more features so that the accuracy will be improved. So that will be done by ratio features. So these are the 4 things we'll do in data transformation. And the next thing is data reduction. So data cleaning, data transformation, and data reduction. So data reduction is nothing but when the dimensionality is very big. You, of course, machine learning efficiently works on large data sets. But if unnecessarily, if instead of using 10,000 lines, suppose for your particular project, some 1,000 lines are enough. Suppose you know that 1,000 lines are enough. Then instead of using that 10,000 lines and wasting the time and energy and the storing space, you can reduce the dimensionality and you can train it by 1,000 lines. So that is nothing but dimensionality reduction, just to reduce the dimension. Or else, for this particular dimensionality reduction, normally we use PCA, principal component analysis. So in general words, PCA is nothing but, suppose in normal sense, normal 2D dimensional, from this view, I can see that I can see some 3 or 4 features. Suppose the same example I am going to take the dog image. So from this view, if I draw that eyes and nose and tail features, I can see only few features are coming in my way, in my view, and I can able to draw a relation between that features and output. But if a little bit, if I can turn that graph from this view, just tilted that graph, from this view I can see more than 3. Then I can say this is the better understanding of features. So the machine can understand better from this view to this view. So I can use this view. So principal component analysis will do that. It's just like tilting that and making more features available and to improve the accuracy, to predictability, to improve the predictability, how we can improve that. That we'll do by PCA. Anyway, we'll see this in detail in our fourth lecture. So this is mainly used to reduce the dimensions of the data. Next one is TSME. This is mostly used in our text images, text classification. So this also we'll see in our optimization techniques in detail. So how the embedded words are reduced, dimensionality of the embedded words, the repeated words, how it will be reduced in our machine learning to improve the accuracy that we'll see. These two are mainly used for data reduction. And the second one is in the same data reduction. First one is dimensionality reduction. Second one is numerosity reduction. So numerosity reduction is amount of data by summarizing or aggregating the data. So for example, you have hourly sales of data. So every hour you have the data of the sales. So instead of using this completely 12 hours or 24 hours data, we can aggregate that and we can make it as a day schedule, day sales data. So just aggregate that, then the data size will be reduced, the numerous values will be reduced, then numerous values will be reduced, the dimensionality will be reduced, and the process will become more faster and more accurate. And this is next one is sampling. In this two types are there in numerosity reduction. One is aggregation and one is sampling. And the next one is data compression. So data compression is nothing but just like what we use to transfer one file to another file. If it is a larger, bigger file, what we'll do? We'll just compress that file in a zip format and we'll transfer. The same thing happens here. If the data is very big, we can able to compress that and we can use that CSV file. Normally in our CSV files we use, so we can compress that our CSV file and we can use that file. So zip file and the ggzip files we'll use to compress our data. And lossy compression is images. So if it is a bigger images, JPEG images and MP3 image, MP3. So if it is a bigger image, what we'll see, we'll compress that by reducing, some resolutions will lose. Maybe the grayscale image, something will be loose, but most of the features will be getting. So the meaning will not be that much affected, but few things will lose. Maybe the resolution will decrease a little bit by compressing, but the meaning will not change. So in that case, we call it lossy compression. But here, lossless compression, when you do that zip file, it won't affect anything. Next one is data cube aggregation. So data cube aggregation involves summarizing the data across multiple dimensions to facilitate efficient querying and analysis. So gathering from multiple sources for analysis, scale, just aggregate the data and compress the data and then make it itself in some separate bins, like just like cubes. So that we call it as data cube aggregation. For example, OLAP cubes. So OLAP cubes actually what it will do, it will store the data like year, quarter, month, or it will be stored in particular location, either city or state. So it will allow you to quickly analysis the data. Quickly you can go to a particular point and you can easily search the data, whether it is noisy data or clean data. So that it will allow. So next one is discretization. So discretization is just like converting the continuous data into discrete bins. So small bins. So just like I told you in Benny, a continuous age will be reduced and make it into ranges. So bins will be created like ranges of ages. and the particular individual age will be stored in particular bin. So it will be easy to analysis. It will be easy to identify whether it is a noise is present or whether any duplication is present or any cleaning we want to do. So analyzing the data is very easy if you create the bins. So one is the binning, discretization. One example is the binning, and one is equal with binning. So suppose I have 100 data here. This may be the range. Sets may be different. Cells may be different, but here equal with binning. Suppose I have 100 rows. So each bin will consist of the same size. So same size, while integrating again after cleaning, when you integrate all the bins, that will be very easy compared to this binning. So equal with binning. And the next one is next step in data processing is outlier detection. So outlier detection, as as already told you, outliers are which are not specifically connected to the particular data. So as the example I already told you, suppose I have salaries of suppose I have 100 rows. In that 100 rows, for the 70 rows, I have salary of some 3,000 to 10,000 range. But the remaining 30% of people, 30 rows, I have the salary of some 20 lakh to 40 lakhs. So when you want to plot the salaries on a graph, you cannot able to plot that. No, one is 22, one is 1,000 to 3,000 to some 10,000, one is 20 lakhs to 40 lakhs. So there may be any, irrelevant. That 20 lakhs to 40 lakhs is completely irrelevant to this one. So that in particular, that case we call that is an outlier. So which is completely away from our data, most of the data. So we can remove, either we can remove or we will see any statistical method to combine those elements with the data. That is the most issue with the machine learning. So if you are not able to eliminate the outliers while building the model, it automatically it will be affected with the outliers. Outliers, maybe machine learning will think that the outliers is the actual data. So suppose I have the same example, 70 lines are in the range of some 3,000 to 10,000, and only 30 rows are in the range of 20 to 40, 20 lakhs to 40 lakhs. But if you are not removing that 20 lakhs to 40 lakhs, so machine model will think that 30 rows are actual data, so it will neglect the 70 rows. So what will happen? The features will not be created correctly. So automatically the model will not create effectively. So it will not predict the accuracy perfectly. So automatically the accuracy will be decreased. So the outlier is the most important issue we have to deal with in machine learning. So first thing, you have to remove the outliers, or you have to adjust the outlier with your complete data using some statistical methods. So to remove or to work with outliers, we have two methods, Z-score method and IQR method. IQR method, we'll see that in details in the next session. And the last one is data visualization. Data visualization, as I told you, how beautifully you are going to represent your results. How you are, how you are going to represent your outcomes with pictorial view. Because there is always difference between how you are going to express your results. Whether it is in numerical way, the same thing 99% if I represent that in a numerical way, and if I represent the same thing in a beautiful graph like this, so they're almost different. So this view is easy to understand, easy to read, and of course it is easy to view. The presentation will makes you better. So always the data visualization will have better effect on the results, on the presentations. So there are different types of visualization techniques are there, whether you are using bar plots or pie charts or some scatter plot or line plots or some cube square bar plots, something. So many different techniques are there in visualization. So this thing we'll see in our next sessions. So, I have only 5 minutes time for our today's schedule. So next class we'll see all these techniques for our lab sessions. So we'll see all these things in our we'll create we are going to use Google Colab. So Google Colab we'll use, and in our next session we'll start with our practical hands-on, how we'll do the first data pre-processing techniques. Then we'll move on to what is machine learning and types of machine learning. And one algorithm we'll see here. I actually did logistic regression, so that also we'll see here. And it's not necessary for you to use only Google Colab. You can use Jupyter Notebook for your projects or Spider notebooks. You just download Anaconda from Google, and you can install in your system. Why I prefer Google Colab is it's no need to install anything, and it's a cloud based, and it's easy to work. And everywhere, if suppose if I'm writing it wrong somewhere, so instead of here, I'm not doing anything here, and if I run this, if I run the code, so it will tell what is the error. So the debugging is very easy in Google Colab. So normally I'll prefer Google Colab for that purpose. Debugging is easy. That also I'll show you in the next class how to work on Google Colab. So time is not enough for today. So we'll wait for today, and hope you will have a nice session, and your time is somewhat valued for your this session, and you'll have some basic idea of data pre-processing. And if you have any questions, you can type it in chat box, and you can ask me now. So still 3 minutes are there. You can, if you have any questions, please type it in the chat box. Or if I'm going speed, if I'm going slow, you can tell that also. So in the next session, I'll improve my quality, and I'll try to make it better in the next session. Thing is there. I'll say goodbye here. Waiting for the comments. If any comments are there, I'll answer now itself. You can ask me doubts, or if you want to know about some any topics in machine learning, that also you can type. So in next class, I'll try to cover that topics in that topics. So please, if you have any doubts, you can type it here. We can see, and tomorrow next early hours, or in the starting of the class, I'll rectify all your doubts. And if you want to know about any particular topic in machine learning, that also you can type it in chat box. And please give the feedback link. We already provided the feedback link. Please give your feedback. That will be helpful for us to improve our quality of delivery. And so thank you very much for listening this much time, and have a nice day. Have a nice sleep. Good night, and thank you everyone.